Hello, friends. Welcome, Polar Void and Dead Nuggy and Fancy Applebee. The crew's all here. We're kicking off our fourth and final installment of our machine learning track. I am super excited. It's going to be some coding, and it's going to be a lot of not coding too. But yeah, the time changed. The time switched up. I mentioned it in the last stream, but at that point we hadn't actually established what the new time was going to be. But yeah, that's on having a job and living on the West Coast. It is, yeah, it's nice to be able to actually work during normal working hours. Let's see. Do we get swag for doing the form? This is such a good question. And it is actually one that I believe so 2 streams ago we did our Kahoot, right? And Embecker, I believe that's a rough pronunciation of the username, did win that, and Mary did agree to give that person a swag drop. I think that we probably will do that for filling out all the feedback forms. I just have to double check with Mary, waiting to hear back from her. Because, I always start thinking about Global Hack Week like around, 4 p.m. Pacific time. And by that time, like, it's past Mary's workday, and sometimes Mary is a trooper and, we'll hang out later. But like, I get it's a job. You gotta take care of yourself. But yeah, we're going to have some good times today. We are going to finish our model. We're going to play around with it. I'm really interested in trying, I haven't tried this yet, but I'm really interested in playing around with what impact does adding and removing punctuation have, because my sense is that probably we could get better performance if we kept punctuation in, which I believe currently we're taking punctuation out. And we're going to play around with making our model beefier. Remember last time we did it, we had kind of a very, very simple sort of word embedding layer followed by one dense layer, and that was it. And so this time we're going to look at making it a little bit smarter. So that should be a blast. We also, as promised, we're going to do the art tour. I already have it. I have a StreamYard set up on my phone so I can take y'all around. I could brag her with cat memes. Yeah, I should try that. No, I know Mary's a cat fan. And yeah, beyond that, I don't know, we're gonna have a good time. I can play the bird song if you want me to play the bird song. Oh, also actually, before we do okay, so I'm gonna show you 4 pieces of art, and then plus a bonus 5th one, which is the final one that I created. I know that last time, 2 sessions ago, I mentioned that I just finished, or I was on the home stretch of finishing this edition that I'm doing, right? I think we talked about it, but in printmaking, it's common. You are carving your blocks and you're doing some test prints, and there's a time you have to be like, okay, it's ready. I'm gonna crank out. You pick some numbers. Sometimes people pick 10 or 100. But being a computer scientist, I knew I needed to pick an even power of 2, and so we picked 32. And I think I showed y'all what it looked like one step before being done. But now I have the finished product. I have 32 of them, and drum roll, please. There we have it. That is Mount Rainier above the clouds. Yeah, I think you can kind of actually get it's backlit a little bit. You can kind of see some light bouncing through behind. So yeah, there you have it. Art number 1 of the day. Oh, thank you for drum rolling. I appreciate that. I love just having the squad come back for the final session. It is a good time. So I guess we're 6 minutes past the hour. I don't anticipate this being a super long stream. I know last time we did. Last time we went for like 2 hours. I think this will be maybe an hour and a half max. So it'll just be casual. Oh, Fancy Applebee, I'm glad that you were able to make it. I hope no big drama is occurring to you. Oh, thank you, Dead Nuggy. I appreciate it. Yeah, I'm pretty pleased with how it turned out. It was a lot of work, but a lot of fun. Oh, you were gonna go to Disney World or Disneyland or something? Well, I will count myself very honored that you chose me. I'm gonna say you chose me above going to Disneyland. 5:30 in the morning. Holy cow! Wait, Polar Void, and remind me where you're based out of. And Dead Nuggy, are you in the same place? I forget. I guess I could narrow it down by just doing the geography and time zones, but we all know that I am not great at time zone math. Okay, yeah, that makes sense. Well, I'm very, very honored that you decided to pull through. Okay, so why don't we do a bit of coding, and then we can do some art, and then maybe we'll do the bird song, and we'll call it a day. So let's get back to. And pardon me while I stall and juggle some tabs. Oh, actually, here's a question for y'all. A weird thing happened on Twitch where I had a separate stream for session 3, but if you go to the archive, it is actually now, you don't see it anywhere, and it is technically tacked onto the end of the Pokemon Showdown stream. Is this the same thing? I don't know if anybody tried to watch the recorded stream and not watch it live. But if anyone did, I'm curious if you were able to find it or not, because that was a weird thing for me to see. Okay, we got a juggle. Well, so it is I don't know, maybe we just didn't leave a big enough gap in between it. But it is in StreamYard, it is a separate stream, right? You can go into StreamYard and you can see separate videos as, yes, this is when you streamed with this title, this is when you streamed with Machine Learning track 3. And that's why I was surprised. Because at first I thought, oh yeah, maybe it just, they were stitched into the same thing, which maybe Twitch does that. Maybe Twitch, if you don't give it, a full cutoff time. I don't know. Maybe I need to ping whoever was doing Pokemon Showdown to actually end the stream. Interesting to hear. You saw it through the preview. Okay, that's the only thing I was concerned about is are there folks who wanted to watch asynchronously and then wouldn't be able to find it? But my sense is that a lot of the folks that watch tune in with us live here, and it's so fun to see you all. Okay, cool. So why don't we pull back up our Global Hack Week Part 3 collab. Oh. And don't worry, I will share my screen in just a second. The problem is I have my middle monitor as the show monitor, right? Because the camera's right there. And so then I have 2 side monitors that are the ones that I can hide things on. And so if I have a window that I want to switch sides, it's oh yeah, I have to stop sharing my screen to switch it. It's very much a problem that I don't expect anybody to have any sympathy for because it's pretty minor. But, oh, where are you? Okay, well, I guess actually I can just drop, I can drop the link to check in. That was from September. Y'all, I really gotta get my tab game together. Okay. Yes, my main one has higher res. Oh yeah, so I have the main collab that I was sharing. I have another one that has, this is, you can see behind the curtain here, is I usually try to go through and do everything that we've done at least once before streaming. And so usually somewhere there is one that is the master copy, I'm trying to find that. Oh, maybe this is it. Okay, this looks good. I think we're in business. Should I just actually go on to collab? Yes, yeah, the mini one has The central monitor has high resolution. It does, yeah. Okay, so here's the problem. This is on me, but I created 2 different collabs that are both called exactly Global Hack Week 2022 10 Part 3, which is just it's not very helpful. Okay, I found my secret notes copy. We're good. We're in business. Right on. So everybody has the link now. Classic Will problems. Am I at the point where I have classic problems now? And let's see actually if OBS remembered everything. I love that. OBS always likes to forget stuff. Okay, so let's do a quick review of where we left off. So you should be able to join from that link that Fancy Appleby so kindly put in the chat. Thank you so much for that. And the link to check in. Gold stars all around. Okay, so in our collab, we import our data. And remember, this is data that has a bunch of satirical headlines and non-satirical headlines. And so we use our handy dandy pandas to read in our training data. We imported a bunch of things, and we took a look at our training data. And so we have headlines. We have whether or not they're sarcastic, and we basically have ignored the article link and the unnamed index column. They're not really important to us. We didn't have any null values, which is great. We described all of our columns just to get a sense of, for one, we saw we have 47% sarcastic, and so the rest are not sarcastic. So we have a slight bias towards non-satire. We dropped some duplicates, and then we built this pre-processing function, right? This function that we ran all of our data through to get sort of a clean bit of text. Oh, this is super interesting. Okay, no, this is actually a totally real problem. So I'm checking back in with the chat. Yeah, because originally the time was set 2 hours earlier, and I guess they forgot to update the actual check-in link. Well, I will also chat with Mary about the best way to handle that. Because yeah, we did change the time, and so you shouldn't have had to check in 2 hours ago. Also, I'll give you the feedback form that I have just for my own personal usage, and you can if you check in there, I'll have a record that you were here. So that's at least something. And actually, I guess I'll drop that now. So this is because it is the last session. I'm both interested to hear, how this one was going. I mean, broadly, it seems like this time most folks have felt like we have timed things pretty reasonably, which is always great to hear. But I am interested to hear if you feel like we're going too fast or too slow today, and then I'm also really interested to hear if you have any recommendations for next time. And especially the I know somebody mentioned, I think it was Polar Voice said, could we do some audio processing? So maybe we think about, trying to, classify songs by genre, or trying to do speech to text. I feel like speech to text actually is a little bit boring. Like everybody does speech to text. But yeah, we might try to do something like that. So, drop any requests or recommendations you have in there. So we built our pre-processing function. I remember we use this idea of stop words to just remove sort of like the very basic ones. We removed punctuation as well. And so our pre-processing basically took all those things out and then reconstructed it as sort of a clean version of the text. We have an example here. We say, we're going to have a great time. And what ends up getting put out is just going great time. And something that I'm actually really interested in exploring in this session is is different kinds of pre-processing are helpful in different contexts, right? So then we applied our pre-processing to the headline, and we got our clean headline data. And so this is what we ran everything on, right? And so we got our labels and our data. And so then we actually set to build our model. We created a validation set. We used this out of vocabulary token that's super helpful in case you come across words because by default, your model is only going to know about words that were in your training set. And so when you go to test it and you show it a word it's never seen before, you need some way to handle that. And so you can replace those with an out of vocabulary token. This still tells your model that something is there, we just haven't seen it before. And so that can be very helpful. What else we got? So then we turn our individual bits of text into sequences. And so you get basically just all the individual ID numbers of the words. Often this would be the step where we would pick a maximum length and say we're going to chop off everything after this. But in this scenario, because our longest thing wasn't actually that long, we said, okay, let's just, what was our max length, like 27 or something? We said, okay, let's just extend to whatever that max is. And so we're only adding things, we're not trimming. And so then this is actually where we got to start having fun, and we built a sequential model in Keras, right? So remember, in Keras, you basically get all of these deep learning tools that are like Legos, and you can just stick them together in layers. And so our first layer gives an embedding for every single word, and we picked an embedding dimension of 16, which was purposefully kind of small. And then we decided to flatten that, so basically just stick all of our words next to each other and run one single dense layer. So this is really, I think, the simplest model that I can think of. And I'm interested in this session to maybe add some stuff and make our model a little bit more interesting. But as we make it more interesting, it'll probably take longer to train. So that's kind of where we're at. Let me know if you have any questions. But the first step that I want to take is trying to beef up our model a little bit and giving it a very, very cool additional layer called an LSTM. So there is this idea in basically all of deep learning that you want your model to be able to capture sort of local relationships in your data. And that's purposely a little bit vague because it becomes different in different scenarios. A classic example is image processing. And I think we saw this in our last session, or in our last Global Hack Week, where we were looking at image data. And we had this idea of a convolutional window, because you could just show all of your pixels to a dense neural network. But basically what that would mean is that your network would end up looking at all of the pixels at once and trying to find relationships between all of them at once with no particular order, right? And we know that that is not the best way to try to process an image, because like pixels that are next to each other actually have a bearing on one another, right? That if you get close to an image, which we'll see later, you will see just a local area of data. And so we use a convolutional window to basically say, well, just look at these pixels that are all close together, and then just look at these pixels that are all close together. And so in natural language processing, in fact, I'm spieling for a second, so I'm gonna make my face big. In natural language processing, you have this stream of tokens, right? And we experience language in this very linear fashion, where you kind of hear one word and you hear the next word, or you read one word and then you read the next word. And so there's this sense that, yes, like the words that are next to each other have some bearing on each other, right? And so this is a big sequence models is like the sort of broad term for this, where you are kind of feeding things into the model one at a time. And you have almost this notion of time in your model sort of like going across the sentence, right? And this is a really cool sort of area of research of architecture. So sequence models are so like things like GRUs and LSTMs are pre-transformer models, and so we do things a little well. In certain cases, we use different kinds of architectures now, but yes, it's a good placing of there's other kind of class of model called LSTMs, called transformers, which I think actually you might consider transformers to also be sequence models. But yeah, they have a different architecture. And so the sort of first thing that folks tried was, okay, what if you have a model that looks at a word and it can make a prediction, but it also generates some internal state, right? And you basically just pass that internal state to the model as it reads the next word. And you kind of keep repeating this, and you build up some internal state that you can then decode and generate some kind of prediction from, right? And the problem that an LSTM tries to solve, so LSTM stands for long short-term memory, and the idea or the problem that it attempts to solve is this problem called the vanishing gradient. And I don't know, we like to sprinkle some sort of serious machine learning theory out there. But the idea of the vanishing gradient is that as you add more and more layers, so I mean, you can think of this both temporally or just by adding layers in Keras here. So if I added, 100 dense layers, if I just like copy and pasted, okay, we're gonna go back to this. If I just copy and pasted this line like 700 times and made it maybe not one, but like 100. If I did something like this, this is, it's still technically a model. Oh, still technically a model that like, in theory could do something. But the problem that you end up getting is, well, besides the fact that we have some kind of error, but the problem that you end up getting is that, okay, this layer at the very end is where your model is making a prediction, right? And there's this process called backpropagation, where basically this layer finds out if it was correct or not. And it has to tell the layer before it, hey, I was right, and this was what you told me that helped me get it right. Or it has to say, hey, I got it wrong, and this is what you told me that messed me up, that caused me to guess the wrong thing, right? And so then that layer has to turn to the layer that fed into it and say, hey, the last layer told me we got it right, and this is the information that was helpful. And this is the information that you gave me that allowed me to give helpful information. Or on the flip side, it says, hey, I heard from the last layer that the prediction was wrong, and this is the information it told me was wrong. And so this is the information that you gave me that led me to providing bad information to the next layer. And I won't go down any more layers, but you can see how as you keep going, you get sort of this, it's called the vanishing gradient, but it is this idea of, well, it's like playing a game of telephone where the signal that you can send back gets weaker and weaker, and it becomes harder and harder to sort of have the early layers really get anything useful out of the training session. And so an LSTM is sort of aimed at this kind of problem, and the math at exactly how it tries to solve this is a little bit out of scope for this, but it kind of has to do with trying to preserve the memory that it has in by sort of selectively forgetting things it does not think are useful. Fez Yahubi asked this, can you be selective about which layers it communicates with? Yes, so there are, this is great. We're getting into like deeper stuff. So there are lots of different things that you can do. I mean, so first of all, we're using a sequential model, but there are lots of models that are have different kinds of architectures and different flows. So like a very common one you will see is a parallel model where you basically, it's used a lot in one-shot learning, where you're kind of asking the question of, are two things the same? So if you're trying to match signatures to one another, you might not have, a million signatures to train on, but maybe you train two separate networks and you just see, is the result that we get at the end of these networks like close enough? And so that's like a big other architecture where it's not just a long list. There's also a thing called the language here, I might not use the exact correct language, but you can send forward a residual. And so you can kind of say, you can almost skip a step. And so you can have your long model, but you could also say, oh, this layer, in addition to sending your activations to the next layer, also skip all of them and send a copy of them to the end. And so that means when you go back, this layer can backpropagate sort of one back, but it can also skip back and tell this layer what it got right or what it got wrong. And so, yes, you actually can be selective about what layers talk to which other layers. And that is, I think what I've said already is probably, we're getting to how deep my knowledge is on the subject. And probably we passed out like the level of depth that is appropriate for Global Hack Week, probably several minutes ago. So LSTMs are gauged at trying to help us with this vanishing gradient problem. And so the thing that we'll do is we'll do a Keras makes it really nice because it makes you not have to implement your own LSTM. But so you can just say tf keras.layers and then LSTM. And inside here, we're going to put a dimension. And this is basically how much memory the LSTM gets to keep, right? So in the same way that we picked an embedding dimension of 16, the LSTM gets some amount of space to remember stuff. And so I actually want to crank both of these up. So let's give the LSTM a memory of 100 units, and let's do the embedding as an embedding of 100 as well. Polarvoid says you might have to run the cells again. Yeah, we'll have to go back and run them all. Oh yeah, that's probably why we're getting the error here. That makes sense. And so now there's one more thing that I want to do. So right now we have an LSTM that, as I told you, we're just going to kind of move forward in space, right? Forward through our sentence. But as we know, sometimes as readers, and this is kind of actually the main idea behind transformers and attentional models, but sometimes as readers, we don't just go forward one word at a time. Sometimes we look back at a word, right? There are so many cool, I don't want to go too deep on the linguistics, but there are so many cool cases where you realize you don't understand the first word until you've read the fifth word or something, because your brain is getting more context and you might go back and look at something. And so attentional models are really good at this, but if you want to make an LSTM better at this, because by default the LSTM is just kind of looping forward every word, is you can do what's called a bidirectional LSTM. And so this is the idea of you build one LSTM that moves forward through your sentence, and then you have a second mirror one that just moves backwards. And so both of them output a representation, and so you can have sort of both information flowing forwards through the sentence and also information throwing backwards. And so if you remember the model BERT, it was a big one several years ago, and the B in BERT stands for bidirectional. Awesome. So let's make it bidirectional, and so we can just actually wrap this layer. We can say tf.keras.layers.flatten, and wrap that, or no, not flatten, bidirectional. Bidirectional, and wrap that in that. Yeah. Oh, and we actually want to flatten after this, because you want to flatten after you've done all of your work as a sequence. So we want to feed our embedded sequence into the LSTM, and then the LSTM output into flatten. Fancy Apple P asks, how many megabytes are in a unit? Units here are a little bit different. If you are familiar with sort of basic neural networks, really when we talk about units, we're kind of talking about like one neuron or one thing that gets activated. And so, I mean, technically the thing that exists as one of these units is like a floating point number that's bounded between, so sometimes you bound it between 0 and 1, sometimes you bind it between other, you line it between other numbers. But I'm having a really, my brain is farting on me a lot today. So a unit, I mean, technically a unit is just like a single number, which I guess if you're on a 64-bit machine, that's, a number is going to be 64 bits. I guess depending on the implementation of Python you're using and stuff. I think the LSTM code is buggy. Expected NDIM3, NDIM2. Let's see. Hopefully the moving flatten down helps this. So that's just because we'll have to run everything again. But okay, yeah. Let's actually go through and run our code. Which really I should have just run it before, while we were waiting, while I was running my mouth. Yeah, sometimes the syntax highlighting and the error highlighting is not perfect. Or it just doesn't work if you haven't run your previous code. Okay, cool. We actually do have an issue, and what are we complaining about? Was not closed. Okay, but it clearly was. Who can spot the bug? Oh, it just literally is. We actually do have a Huh. I guess we have an extra parentheses right there. Is really what's going on. Yeah, so the LSTM is going to make things take a lot longer. This is actually a big reason that now we see more usage of attentional models, because you can parallelize attentional models much better than a sort of LSTM style sequential model. And so it will absolutely take longer, and that is to be expected. A-okay. Cool. So we've compiled it. You can also see that our this number of total trainable params has just exploded, right? Which usually number of total trainable params is a good proxy for both, how powerful your model can be, but also for how long it's going to take to train. It's not like any kind of direct one-to-one, but it gives you sort of a basic sense of it. So yeah, we'll try training for 5 epochs again. I remember an epoch is sort of one iteration of your model seeing all of your data. Cool. So it absolutely is taking longer. Ooh, and this is actually interesting. This will be a fun. Okay, actually, what I really want to do, I don't want to muck around with having to stitch histories together. So I want to run this for 10 epochs. And it shouldn't. It'll take maybe 50 seconds. Next time, let's do TPU compute. That could be fun. We can actually do one, we could do a session all on hardware. That could be good just for me to learn more about hardware, Oh, wait, that's not what I wanted. I wanted to start it from scratch. Okay, so we're going to recompile our model and run it for 10 epochs, just to get a sense. The thing is, Polar Void, you were the one that actually originally brought to my attention that I was not using the accelerator correctly in Colab. So I feel like we'll do it, and it'll be like, wait a second, Will, what's going on here? Which it would be good. It'd be a good learning experience. But how about this? I'll do it if you come and do a drop in, and I'll send you an invite link. Okay, so this is actually great. So the first thing to realize is at this point, it actually is not doing that much better than our original model that was much smaller. And so maybe we could play around and actually move this closer to what we had earlier. But one thing that I do want to look at is I want us to graph our results. So we're going to do just a quick. Actually, let's write a function so we can reuse it. So did we already import matplotlib? Matplot. We did. Okay. So we can already use it. And so we can say plot graphs, and we'll take in our model and a string. And so we can say plt plot, not splot. Plot model.history and string. So here, or really we could say metric. So we'll pick which metric we want to graph, and that's the one that we'll grab from our model's history. And then we can get the validation of that metric. So as your model is running, it's collecting a history of how it's doing at every step. It's really the data that we're seeing printed out here. We just want to get it in a graphical format. But it's also always recording both the accuracy and the validation accuracy, and the loss and the validation loss. And we can say plt.xlabel epochs. PLT Y label. We'll call that whatever our metric is. PLT show, and let's add a cute little legend. So this is basically us constructing a graph that we'll be able to render. Which is honestly, knowing how to make good graphs with Matplotlib is honestly very powerful. I won't say that this graph we're making is like going to be to die for, but it's going to get the job done. And so now we can just use our function to plot graphs with accuracy, and then also with loss. And okay, great. What did we get wrong here? Our legend looks super weird. Oh, string, metric. I'm gonna try that again. Okay, awesome. I guessed about the GPU because I do some game engine dev. Okay, I see. Yeah, metric, not string. Y'all are sharp. Nothing gets past y'all. So let's look at our graphs. Really interesting stuff. So first of all, let's look at so accuracy and loss kind of move in opposite directions, right? Your loss is like a bad thing. You want to minimize your loss, but you really want to maximize your accuracy, right? And so our accuracy and loss, like normal, are the ones where basically we're being tested on the training set, right? This is kind of like when you're given a study guide and the test is the study guide. It's like you've already seen all the answers. It's just, can you remember them, right? But then for validation, that is checking something that the model hasn't seen. And so that should be a sort of better test of how this model is going to generalize on stuff it hasn't seen in the future. And so a really interesting thing happens here. So for starters, we can't just looking not at the validation, but just at the accuracy. We can see the accuracy goes up and the loss goes down. And this is good, right? If this was not happening, we'd be very concerned, right? But what is concerning is the fact that our validation accuracy, it basically is, except at the very beginning, it actually is getting worse, right? It's going down, and our loss is actually going up. And so this is one of our classic big things that we want to avoid in machine learning is overfitting. This is when you have basically just memorized the study guide to your test, and so you're not going to actually perform well on your test. And so there are lots of different ways that you can deal with this. One is giving your model a smaller capacity, right? If you give your model a smaller brain, it's not going to be able to just try to memorize the answers. It's going to have to try to learn. But the other thing that you can do is you can add something called dropout. And that's one intervention that I want to try first. So we'll save these graphs just as a record here, but we'll come back up and we will, here, I'll actually, what's the best way to do this? We'll just leave this cell. It's fine. Okay, so I want to come back up and add a layer of what's called a dropout. And dropout is basically says, let's just add a little bit of noise to your network. Let's make everything a little bit fuzzy. And this is a way of basically making it harder for your network to remember specific examples, because every time it sees the example will be a little bit fuzzier. And so one way we can do this is just by saying tf.keras.layers.dropout. And you get to give it basically a percentage of dropout. And this is basically how fuzzy does it get, right? So your input units will get randomly scrambled at some rate. It's common to just try 50% as a default thing, but you might try something smaller than that. So let's recreate our model. Oh, we need that comma. When will the intro to Unix session start? A great question. Actually, is it possible it's already happened? I think that it did get. So I think I actually swapped with the intro to Unix session, so that would have happened. 2 hours ago. But it should be recorded on Twitch. Okay, so let's create our model. Let's compile it. You can see this did not actually increase our number of trainable params. Dropout itself doesn't actually mess with that. And so now we should be able to train again. And this should not take any. It's possible it might take a tiny bit longer. but that shouldn't be much. Okay, cool. So this is actually great. So if you remember, I think I have this this tendency to say whatever happens is like, oh, this is incredible. This is what I wanted to have happen. But so you see our raw accuracy actually takes longer to improve. And that makes sense because we're making all of the examples fuzzier. We're making it just giving it a harder task on training with the dropout. But the hope is that this keeps our loss from our validation loss and our validation accuracy from worsening quite as much. And it looks like they are getting worse, but not that much worse, but maybe not quite as worse. So we could plot our history again. We can say, oh, after adding dropout. And so we could look at, I wish a better way for us to format these side to side. But so here our validation loss is getting up to 1.7. If we come down here, oh, well, that doesn't really prove my point at all because here it peaks at, it looks like 1.6. So that is, I would say, not precisely what I would have expected. So the other thing we talked about, if we want to combat our overfitting, the other tool in our toolbox is reducing the capacity, right? And so, I mean, we could just get rid of the LSTM, which would be honestly probably a good idea because it'd make our model much faster. But the LSTM is fun. So what if we just made the LSTM smaller? What if we said, give our embedding size, it was originally 16, what if we made it 32, and we made our LSTM 32 as well? And this is something that I'm just curious to see, how does this affect our overall performance in addition to our accuracy and validation accuracy? So again, it does take us sort of longer to get up to those high levels of accuracy for our training data. But really what we're looking for is, does our validation performance get worse? And does it get that much worse that fast? I'll also say we're running 10 epochs, and depending on your task, it is not uncommon to say, well, no, we really need to be running, for 300 epochs or whatever. I mean, generally, it's usually an approach that if your validation performance starts getting worse, that's when you know, hey, stop trying to, stop going. And okay, so this is, we made some progress. So this was after adding dropout and reducing dimension to, what was it, 32. And so here our validation loss, it looks like we're not getting upwards of 1.4, which is good, right? And our accuracy is still hovering kind of in the 77% for validation, which that is not that much different in any of these. Polar Void says, what about modifying our activation functions? This would be a perfectly interesting thing to give a shot. I mean, I guess oftentimes you think about modifying your activation functions for sort of internal dense layers. So activation functions are really important in dense layers. But there are also things that you can tweak on in other layers. So, I mean, actually, can we, let's see, Keras, LSTM activation function. So, okay, so this is actually an important distinction. So the activation for its output is different from its activation for the internal state that it sort of passes forward. And so my understanding is that the recurrent activation is that internal state that's getting passed forward, and the normal activation is sort of what it's putting out into the world. And so we could, I mean, like often a thing that folks try is changing sigmoid to ReLU. You pass none, no activation is applied. That's interesting. wonder if we even just, I don't know. I'm kind of into just not derailing, but turning this into let's look at all our Keras activation functions. Keras activation functions. Okay, so ReLU is like, everybody loves ReLU. We're always a fan of that. The sigmoid is pretty basic, but we live with it. Softmax is, I mean, like the sort of dumb way that I would describe softmax is it's basically sigmoid when you have multiple classes. Soft plus, what does the soft plus look like? I'm kind of curious. Soft plus. Let's take a look at what this function looks like. Okay, so this looks like roughly ReLU function, but not quite as angular. But yeah, yeah. Well, Polar Void, I'll say given the session was originally going to be pretty short, I'm like, yeah, let's take a detour on activation functions. But the real thing that I want to give a shot is adding back in punctuation and seeing if that changes things much. So why don't we give? Let's see, can we just say activation equals ReLU? If I thought it was a dumb way to get sidetracked, I wouldn't do it, you know? Cool. Ooh, okay, so this is taking much longer using the ReLU activation, which is, I guess it's a blind spot in my machine learning knowledge. I've never really actually thought about the performance implications of different activation functions. I've always just kind of thought of it as like yeah, it's some quick math you do. You just pick one and you see how it performs. I mean, so one thing that people will say is that ReLU can help you with the vanishing gradient problem because the numbers, they can't get much lower than, or they can't get lower than 0, but they can get very, very positive and high, which is, allows you to have a larger gradient for longer. So you're not multiplying a bunch of really small numbers together. So maybe while we let this run, just because I am interested to see where this goes, and folks, welcome to really the art and science of machine learning is you have a theoretical basis and you're like, yeah, let's try that, and you come back a few minutes later and you're like, oh, it was worse, or it was better. Hopefully it's better. But we'll let that run and we'll come back and we'll see, okay, what do we have to change if we want to try this still with punctuation? In fact, I mean, really, actually, all we'd have to do is just comment out these two things, and we'd have a preprocessed function that leaves in our punctuation and stop words. So I guess that's what we'll do is we'll comment this out and we will come back and we'll run all of these again and try leaving in stop words and punctuation and see what that gives us. Yeah, this is quite slow. I don't like it. I guess it did warn us that LSTM5 will not use, I want to say CUDA, but it's CUDNN kernel, since it doesn't meet the criteria. It'll use generic GPU kernel as a fallback when running on GPU, which, I mean, I'm not low enough to the hardware to tell you exactly what is going on here. But it is certainly suggests that we're not taking full advantage of our hardware with this new activation function. But is there a reason we aren't using a limitizer this time? Great question. Honestly, just variety. I try to throw different things in, so we talked a little bit more about linguistics and pragmatics, and we did not use limitizer. So for those of you playing along at home, lemmatization is this way of, it's kind of like in the same vein as removing stop words, but it's a pre-processing step that basically turns words into the simplest versions of themselves. So like a common example is happy, happier, and happiest will all become happy. And that is sort of like a way of sort of reducing some of the complexity. And so do we use that on the sentiment analysis project a while ago? But yeah, the honest truth is, I mean, time and just trying to get variety in there, you know. Let's see, four ways, free platforms to run this for free. Yes, yeah. So lots of great options. Does Amazon SageMaker Studio Lab, does that have a free version? I'm curious to hear I'm sure there is, but I'm curious how the free tier performs. Cool. But yeah, I use Colab just because it's what I'm used to. But it is a great thing that the Jupyter Notebook interface is something that is pretty standardized, and so you are likely to have almost good. I mean, this is me not shilling for Google, I guess. I think Colab is great. But the experience that you should have should be relatively similar for these different, if they're Jupyter Notebook based is kind of the underlying model. Yeah, it does not seem like we're doing great. We're not doing much better. I notice the longer a model runs, the faster it gets. That's interesting. Is this like an observation of, oh, I guess just here it's like, oh yeah, 43 seconds, 40 seconds. I'm curious if anybody has like big, like if you have a guess as to why that is, because my mind first goes to the notion that, oh yes, this is running on shared hardware, and you have a lot of interesting hypervisor stuff that goes on where there is a central authority that is deciding who gets how many CPU cycles, and that if you have been running a task for a long period of time, you are more likely to have things loaded into cache, and you are more likely to to sort of be at the front of the line to be able to run your cycles. It could be something totally different, but yeah, my intuition is that's more likely to be a product of the platform that you're running on than more likely to be a product of the platform you're running on than like the model itself actually becoming faster. Yeah, I guess we're roughly on the same page. Good stuff. So, oh my goodness, actually, the validation loss has gotten very bad. So I'm going to let it run just because we're close. But if you're not using GPU and you're just slower, you can press the pause button right here and just bail out. I don't think this is going to be I don't think this is going to be what we want, right? But let's see how it does. Adding dropout, reducing dimension to 32, and using ReLU activation for LSTM. Maybe after this, I'll go and look up why is ReLU a bad option for LSTM. So yeah, definitely not great. Our validation scores are the worst they've ever been, it looks like. I mean, our accuracy is not much worse, but the loss is much worse. And actually, so here's maybe a question on well, hey, why do we care about the loss, right? Why don't we just care about accuracy? If most of these have just been getting about the same accuracy, what's the big deal? And I would say that the way that I would frame it is that because loss basically is able to assign partial credit for not being confidently wrong, that loss gives you more information about how it might fare on things that it won't see in the future, right? That your accuracy is going, even your validation accuracy is just going to be very tuned to, well, what is the specific data that we have in our validation set. And so it's a good idea to look at both your more nuanced metric of loss in addition to your sort of final metric of accuracy or F1 score or whatever whatever metric you're using for sort of final reporting. So I actually don't think that we. I want to before doing anything else, let's get rid of ReLU because I think that was an interesting experiment, but it was much more intensive and didn't seem to really help. And so we'll remove that, and now we'll actually run this, and basically this keeps our punctuation and stop words in there. And I'm curious to see how this goes. So we're just running all this again, but with our stop words. Oh, and actually, this is super interesting. So let's see what our new max length is. Okay, so our max length is now 40, which is actually much longer than our max length used to be. I think it was 27 last time. And because we're leaving in the stop words and the punctuation, that just creates a lot more tokens. And it is possible that actually could cause issues for us. So why don't we try to basically keep the same max len, and so we'll say max len is equal to the min of max len, and let's say 30. Actually, sometimes they say it is like better to do your max length in the sequence in some kind of unit of powers of 2 because you get some nice properties when you're loading things into cache. But I'm simply going to ignore that advice. Cool. And let's let it rip, I guess. And hopefully it's faster again this time. Okay, cool. We're back to being speedy. Whoa, pretty high validation accuracy out of the gate. So it seems pretty clear that information of punctuation and the stop words is helpful, right? And I think this is like actually a good way of looking at the different pre-processing is helpful for different kinds of tasks. Yeah, I'm interested in actually looking into why ReLU was so slow. It also actually added parameters, which is not a thing that I would have guessed. So yeah, I'll have to do some reading on rectified linear units in the future. Okay, cool. So let's graph this after adding in that punctuation and And okay, cool. We're definitely in a better place. So our actual accuracy, our validation accuracy is just better. Our validation loss is better. I think there is something that is a little bit concerning, which is why do we just see the longer we train, our validation loss gets worse, right? And that's a thing that I think like rightly should concern somebody. And yeah, that is my basic understanding of ReLU is you take the max of 2 numbers. It might actually be, it's possible that the reason it takes longer is not actually on the forward computation, but it's actually on the back propagation. That if it is harder to optimize getting the derivative of the thing, that might be a case where you're getting more. But that's just a total speculation. I'm not sure. Okay, cool. So we're doing better by adding this information in, and it's like a cool learning that when trying to identify satire, those details of stop words and punctuation actually seem to be helpful. You could also make the cynical take, which is also probably true, which is just, well, hey, this isn't all satire. This is specifically the Onions kind of satire, and so they're going to have very specific signatures that your model can pick up on, which is probably fair. I won't say this is, I don't think we're going to get to publish this. I think there are some issues, but I think it's super interesting to see that, oh yes, those stop words and punctuation are actually really useful. So because we're concerned about, oh yeah, let's update our lab notes and keeping stop words and punctuation. Okay, so one more thing I want to try is I want to mess with our architecture a little bit, and I want to say, what if we made our embedding size even smaller? I mean, heck, what if we brought it back to our original 16? historically, or like theoretically, that's actually a really, really small embedding size that, that shouldn't often be your first pick for like your first pick for an NLP task, but I'm interested to see how it does, and I'm also interested in adding one more dense layer. We often think of like layers like LSTMs and GRUs as being useful but not very general purpose, right? That you're going to get a very specific kind of processing of sequential text data, but that if you just throw on a dense layer, let's say after a dropout, what if we say TF, Keras, layers, dense, and it doesn't need to be huge, say 32, and let's give this an activation of ReLU. I want to give that a shot. So we're making our model smaller, or a smaller embedding dimension, but then giving it one extra dense layer at the end. To see what that does for it. Which I guess also, if I'm going to be a Stoip words, I'm just trying to spell it like Blahaj. In some pure science sense, you would only want to try changing one of these things at a time, right? But so like ideally what we'd like to see is our validation loss like level off, right? We'd like to see our validation loss not continuing to climb the more we train it. And we still, so it is again it is lower, but we are still seeing it climb. We aren't scientists, we're mad scientists. Yeah, we're just having fun. We're just playing around. So I guess the other thing that maybe is interesting to try is you see here, it's like we're getting to, I don't want to say it's an inflection point, but it does seem like loss ends up possibly turning around. And so I'm curious, what if we just run this for, let's recompile the model and run it for 20 epochs. Given that it's pretty fast, we can do that without much cost. But yeah, if you're keeping your professional research notebook, I mean, really, you would automate this. There's a thing called hyperparameter tuning, which is basically building a. I mean, the way that you usually do it is you have a loop that says, well, hey, try these, try these 10 different values for the embedding size, and do k-fold validation for all of them, right? And you will kind of repeat that for all your different values, and so you can just say, yes, this is the set that seems to work well. So it's a lot more rigorous, and you're only changing one thing at a time. I think we're doing a lot of learning here, and we are also trying to make it interesting and have a sense of drama and fun. But yeah, our validation loss is still climbing, which is some would say troubling. And I mean, I suppose at some point you would expect that it levels out a little bit, but as long as we've been running, it's been going up. So I might give it one more shot. Ooh, validation loss very high. I might give it one more shot with, and it's not hurting our accuracy, right? Which is good. I give it one more shot, actually just taking out this this dense layer. And so we're really trying to keep our model quite small at this point. Yeah, I think that is the. I mean, we're it's funny. I feel like we've gone on our hero's journey where we have added a bunch of things and we have decided, well, what if we take that out? What if we take that out? And eventually we'll get back to the model we had yesterday, right? Which was, I do believe that one change that genuinely has helped has been adding back in the punctuation and stop words. But beyond that, I don't think I don't think much of the extra capacity has really been that helpful. Which is, I mean, it is a good thing to regularly test out. Is this extra capacity that I might be giving my model, is it actually helping, right? All right. Are we gonna get a validation loss leveling off? It seems possibly not. Oh, this stream's. I mean, you can never bet once you've only seen 3 data points, but. So the LSTM is the long short-term memory layer that we introduced. I think it was the first thing we introduced, which basically goes through our sentence kind of word by word and is able to feed forward some information from the previous bits of the sentence. But yeah, let's let her rip. Let's take out the LSTM and let's see what happens. And now it should be super fast. Validation loss still climbing. I think we are doing better. I think that is correct. I mean, on our training accuracy, obviously we've been hundreds all around, but it does look like we are not worsening as much with our validation, which I think that might be where we leave it. I think that might be the move. So I think what we're gonna do is we're gonna take a break. We're gonna do the art tour that I promised. I don't know was it Fancy Appleby? Was it you that I promised like one Global Hack Week ago that we would do it? I know I promised somebody, but we are going to go on a little tour of Will's place and look at some art. And I'm gonna have to reopen the little invite. Let's see. Oh, also, I might have to. The audio is going to be weird here, so apologies if the audio gets weird. So we're going to do that, and then we're going to come back and talk about what did we learn, what was useful here. Oh, that's funny. It doesn't want to use Chrome. StreamYard wants to use Safari on my phone. Okay, if you start hearing weird audio things, you know what's going on. I have an iPhone. So I had a Pixel 2 back in the day, and I really liked it. And it was great, and I thought that was awesome. And then my mom was like, "Will, we missed you on iMessages. Please come back." And so I have an iPhone to improve my relationship with my mother. That's where we're at. Which, I mean, to be fair, I'm not that. I do like it, right? I think iPhones are nice, and I think the integration, I think the Apple Watch is absolutely the nicest smartwatch out there, and I really really like my MacBooks. So I'm not that begrudging about the fact that I have an iPhone, but I think the Pixel is awesome. I can't speak to any other phones because I haven't had them. Okay, Enter Studio. Are we gonna get weird audio? Oh yeah, we are. I don't know if you can hear that. Okay. Maybe this is gonna work now. Yeah, Wilchin. Okay, we're on the move. Oh wait, I want to actually. I'm gonna flip it. I'm gonna have to flip it around. And actually, let's do that. How about that? Okay, we're on the move. So yes, this is my home. I guess y'all you see the study a lot, and you also see the kitchen downstairs with coffee. But apologies, things are a little bit messy. We're gonna go on a tour of 4 different Japanese block prints. 2 of them are by the same artist. So actually, let's go downstairs for our first stop. So as I mentioned, if you're here for the last session, I've gotten really obsessed with Japanese block prints. It is to me a very cool process where you carve into wood and you make these impressions, and the quality of what is able to be produced just by carving on wood to me is very, very incredible. Also, let's see, can I still see the chat? Oh yes, okay. Yeah, so this is a townhome. It has 3 floors and then like a rooftop garden area place. Yes, we're going on an adventure. Okay, let me see if I can flip around my camera settings, back camera. Okay, so this is block print number 1. It is called Snow in Kamigamo Shrine. The glass on it is relatively reflective, and I apologize for that. But it is a striking piece. It was in, I believe, the sort of like later part of the first half of the 20th century. So this is a period in Japanese block print art called the Shinhanga movement. That is, I think it literally translates to new prints. But it's like very focused on just how much detail can we get in there, how realistic can we make things, and so very fun. You got really, really bright reds and really, really cool whites. I think it is cute. See, this is okay. Y'all can see it. Okay. I was concerned that changed. Okay, sweet. So we can now go explore the next one. Hopefully you got a good long second to look at it. And that is probably, I don't know, that ranks probably number 2 or 3 in the collection. Okay, so number 2 is from an artist called, I'm going to totally butcher this, but it's Tsuchiya Koitsu. And this is actually a gift from my mother. And it is a little bit smaller, but I am absolutely in love with like the sort of contrasting colors and just that sense of depth. I think in general, I'm a sucker for works of art that have both humans and natural, or sort of like human and natural elements in them. I think that like interface between sort of, quote unquote civilization and city life and then the natural world is super interesting, and I dig it. Yeah, absolutely. I mean, so this definitely, so I'm getting comments of reminding folks of anime, and I mean, like, it certainly is there was this originally this connection between like the same folks that were making this kind of art were like also making the early manga, right? That in fact, actually, we talked about the Katsushika Hokusai, who did the Great Wave. Was also an avid maker of manga, and so have a lot of there are a lot of Hokusai manga out there. All right, maybe the next one we'll see is Bamboo or Bamboo Grove Saga. Also, I'm kind of proud of this shelf because I built it. So hey, I built a shelf. But big fan of this one. I know I'm telling you I like all of them because obviously they're art that I picked. So really a big fan of the gradations of color. I'm actually colorblind, and so a lot of the things that I say about color are like, you might not experience color the same way as me. But you have just a really, really nice blurring of blue and green, and a really cool way of showing depth. Where if you look at the very back, you have these sort of light silhouettes of bamboo that are further back that don't have that outline, sort of back there. So. Also a big fan of that. And this is also Asano Takeji, which was the same artist as the first piece downstairs. Let's see. Let's check in with the chat. Folks like the frames. Is that an IKEA shelf? Yes, yeah, I made the shelf. I'm proud of it. Yo, I actually would love to do some woodworking next time. That would be a good time. Okay, and so then finally, the pièce de résistance is it is probably my favorite piece, and is by an artist called Kawase Hasui, or I don't know, Japanese names. Sometimes we translate them by swapping them because we do, sort of given name in front of family name. But I think most people would say Kawase Hasui. And he is kind of of this movement of the Shinhanga period, which is kind of the early half and middle of the 20th century. He is kind of the granddaddy of that movement, and has just some really incredible prints. And so we will come around here. And so this is also going to mess up the pronunciation, but Chuzenji Lake. And this is so much going on in this print. I'm a really big fan of the gradations of color. So obviously you have, like the sort of deeper blue in the back of this lake to the lighter blue in the shallow. But you also have this really cool gradation in the leaves here, where you get kind of the light hitting the tips of the leaves with that sort of gradation from like the cool green to that brighter lighter. We are always a fan of some intricate shadow work. So down here, you can just see some really killer shadows that are just really precise. And, on top of all that, we get some classic Japanese iconography and some folks going on a journey. So what's there not to like about that? So I guess that is probably, maybe I'll turn the camera back, or maybe we'll just make our way back to the workshop. Whoa, and you can see how messy my desk is. You can see the setup. Whoa. And we're just going to thank you for letting me know. Yeah, it was you spoke too soon when you said seamless transition. I was like very thrilled that I had seamlessly transitioned back to the desk, but those that dang mute button. But yeah, that was. Oh, I mentioned it's not a Keychron 2. It's a Keychron. Or sorry, it's not a Keychron K2. It's technically a Keychron Q2. I believe the main difference is that this has hot swappable switches, so you can swap out the switches without soldering. But yeah, I have a K2 in the office. I am glad y'all enjoyed the trip. Yeah, that's currently all the art hanging in my apartment. But hey, maybe a few months from now, when I've swapped some of it out, we can do another tour. Bob Ross of AI and Japanese block art. I would accept that title. I'd be thrilled for that. I have browns. In my keyboard right now, and in the one at work actually. So yeah, we're back at the desk, and I think I would just want to do. If I wasn't using browns, I think I want to use blues. I'd be a fan of some blues. But I guess we should do a little bit of a wrap up on what we actually learned this week, and then I'll play you out with the bird song. Yeah, clickety clackety. Okay, so what did we learn? I want to actually bring it back a little bit to linguistics, and the reason that I want to do that, I know I started off with just probably way more nerdy linguistics than was appropriate, but often there is domain science that is really helpful when you are building a model. And the reason the domain science is really helpful is because it can help you understand the theoretical limits of what your model can do, right? So, if you are building a model trying to establish house prices, maybe you should actually go and try to talk to some real estate agents or talk to folks that actually watch the market and realize that there is some amount of noise in the market that really is not accountable for, right? Or maybe it is, you are trying to identify sarcasm, and if you talk to a linguist, they will tell you, yes, there is this idea of semantics and pragmatics, and that pragmatics, which sarcasm is a type of, really requires context, right? And it is really hard to tell if somebody is being sarcastic unless you know what their position is in the conversation and what might actually be true for them. And we saw that both in our personal data set that we scaled, and then also in our big data set that we pulled from The Onion and Huffington Post. And so that I thought is just a cool thing to talk about, that getting into the domain science and trying to find domain experts or becoming a domain expert yourself can be a really good way to ground the machine learning that you do. I guess after that, we looked at sort of our basic exploration of TF-IDF to try to identify those meaningful words. And I'll say that exploration was, like, compared to a lot of ways you can use that, kind of a bust. I will say that TF-IDF, I think, works best when you have lots of different categories. So if we were trying to classify topic between 16 different topics, I think TF-IDF often shines there more because you get sort of a broader notion of what is common. But in our case, it did not actually yield things that were that much indicative of sort of common sense sarcasm. Although we used it and it was able to, I believe with around a 70% accuracy, identify things. So it didn't seem like it taught us that much, but it built a model that was not useless, right? And so then I guess the final big learning from today, that to bring it home, is that bigger is not always better, right? Is that it's really cool to pull out all of these neat little toys from the toy chest. And sometimes they're really, really useful. And when you get into, really intense things, when you are trying to build a chat bot or a virtual assistant, really having a robust understanding of language. If you're trying to do machine translation, you really need to have these bigger tools. But if you are trying to do a binary classification, that you really should try to keep your model as small as you can without it actually hurting your performance, right? You do not get any kind of bonus for your model being large. And so one great metric to look at is the number of tunable parameters. So in our case, our final model here had 395,000 parameters. And yeah, I think that is about where we're gonna leave it. Let's see. Oh, great. Fancy Albie says I let it run for 100 epochs and my loss is 1.05. Okay, cool. That probably, I'm curious to see what your graph looks like, but I would guess that really means that it has kind of leveled off somewhere. Which also, actually, what if we graph this last one here? Okay, yeah. So this is super interesting. A much different loss curve. And one that looks like it is at least increasing much, much more slowly. And then Polar Void said, didn't our model do better than we did in the end, though? Oh yeah, this is actually, this is a great thing to bring it back to, is the grounding your model and having its ultimate comparison be human performance. And yes, like when we were cahooting ourselves on our own data set, I believe that we averaged 54%. Which is better than random guessing, but just barely, right? And within the margin of error, given how few samples we had. And so, yeah, we were able to build, 4 sessions later, we hopefully learned a lot about machine learning. We learned a decent bit about linguistics. But we built a model that is better than our human performance. So I guess that is, unless we have any other questions, which y'all always have the best questions, we will wrap it up, and I will play you the bird song, and we'll close the blinds on another Global Hack Week machine learning track. Do I take friends on Discord? You absolutely can try to add me. I just never use Discord. I will confess, I get on Discord 4 times every Global Hack Week, and that is to post the announcement that I'm doing a stream. That's it. I used to get on it more, and I would like to. It is just, folks, it is a busy life, but yes, feel free to add me, and if I see you and you have a username that's one that I recognize, I'll for sure add you. But it might be a while since I'm back on until I'm back on Discord, which I'm sure you can hear the Discord notifications in the background, and you're like, "What are you talking about? It's up," and it's because I just pulled it up to post the announcement. All right. Oh, okay. This is actually another great thing. Before I play us out, I want to add one song to my Kalimba repertoire. Is that how you pronounce that? Repertoire? Let's look it up. How to pronounce repertoire? Repertoire?
Repertoire.
Repertoire. Repertoire. I'm going to say that 10 times fast, and it's not going to sound like a word anymore. Repertoire, 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 repertoire. Huh. So the last thing that we're going to do before I play us out is drop that feedback link. And so I would love it if you have ideas for future sessions, or if you want to recommend a new song for me to learn on the Kalimba. I'm not going to learn like 13 songs, but I would love to add one to the repertoire. Alrighty. So yes, this is my song that I wrote about the truth about birds. I am so unsure about so many different things that I have heard, but there's one thing of which I am certain, that the government invented birds. They are fake, you can see it in their eyes. They're the NSA's favorite little spies. But there's one thing of which I am certain, that the US government invented birds. Stay woke, sheeple. All right, that's the song. Thank you so much for tuning in to Global Hack Week Machine Learning Track. It has been an absolute joy to have you here. And I look forward to seeing you next time. Happy hacking. And I hope you have a great rest of Global Hack Week. And solid work, everyone. All right, see ya.